Hello friends, in this video we will learn the Simpson's one-third rule. So first we'll see the introduction. The region enclosed by the curve f of x and the x-axis within the limits a and b is represented by integration I is equals to integration a to b f of x dx. So we'll see with the help of graph. Consider one curve f of x and its initial limit is a and b. So area under this curve is nothing but the integration of this area under the curve. So first we will divide this area into small number of strips. So start point is x0, then x1, x2 up to the xn. So these divide this entire area into small number of strips, and on x-axis coordinates are x0, x2, x1, x2, x3 up to the xn, and related to the y values are y0, y1, y2 up to the yn on y-axis, on curve. So once you divide this area, then we have the apply this Newton forward difference method to find the integration or to find the area under the curve. So integration a to b f of x dx is equals to, after applying the Newton forward difference method to this, to calculate the area, n h into bracket y0 plus n by 2 delta y0 plus n into 2n minus 3 upon 12 delta square y0 plus n into n minus 2 bracket square upon 24 delta cube y0 plus up to the nth term. Here for Simpson's one-third rule, put the n is equals to 2 in this equation, we'll get the Simpson's one-third formula. If we put the n is equals to 1, then we'll get the trapezoidal rule. N is equals to 2, Simpson's one-third rule, and n is equals to 3, then Simpson's 3/8 rule formula. So this is a Newton Cotes formula. So here in this case, the Simpson's one-third rule, we have the 3 points x0, y0, x1, y1, x2, y2. Then consider previous this entire area, which is we have already divided into small number of strips. So n is equals to 2 means consider here the first two strips area means one area, that is a1. Then next two strips area, that is a2. Then next two strips area is a3. Then these step size for each strip is h equal number of equal step size for this number of strips. Then initial limit is a and final limit is b. So consider first two strips and we put in the x and y coordinates. So first two strips, and this is a curve related to the coordinates on x-axis x0, x1, x2. So we will consider here the a is the initial limit and b is the final limit for first two strips. Area is a1 and step size is h. And on curve y coordinates are, first is ya is nothing but the y0, y1, and this yb is nothing but the final limit or y2. Then a and b is x0, a is x0, x1, x2 up to the xn minus 1, and b is xn here in terms of x coordinates. Then we have the Newton Cotes formula, and already we applied there the Newton forward difference method and put the n is equals to 2 in this equation. So where delta y0, so delta y0 is nothing but the y1 minus y3. Then delta square y0 is equals to y1 minus 2y1 plus y0, and delta cube y0 is y3 minus 3y2 plus 3y1 minus y0. After putting this value, n is equals to 2, and this all delta values, delta, delta square and delta cube y0 in the Newton-Cotes formula, then we get the Simpson's 1/3 formula. So integration a to b f of x dx is equals to h by 3 into bracket equate first and last term after simplification of all and after putting the all values y0 plus yn first term plus 4 into y1 plus y3 plus y5 up to the yn minus 1 plus 2 into y2 plus y4 plus y6 up to the yn minus 2. So this is the Simpson's 1/3 rule formula. So we can remember this formula in this way also. Integration of a to b f of x dx is equals to h by 3 into bracket y0 plus yn plus 4 into, if we see here the all odd terms are there, so 4 into odd terms plus 2 into even terms. So this is the Simpson's 1/3 formula. So after this introduction, we'll see the one numerical based on this concept. So numerical statement is evaluate integration 0 to 4 ex dx using Simpson's 1/3 rule using 4 strips. So solution. So given data is initial limit is a is equals to 0, upper limit b is equals to 4, and number of strips are given 4. Then here strip size is not given. So strip size, how to calculate? That is final limit minus initial limit upon number of strips. So here formula becomes h is equals to b minus a upon n. So put the value of b is 4 minus initial limit is 0 upon 4. Then we'll get the strip size 1. After getting this strip size, then graphically we'll see here the first 2 strips area means first area, then next 2 strips is area A2. In this way find the areas A1, A2, A3 and then take the summation of these. And coordinates are x0, x1, x2 up to the xn on the x-axis. And step size is h, equal step size is there. Then find the x0, x1, x2 up to the xn. Here xn is 4. First x0 is given here the 0. Then x1 is how to find x0 plus h. Step size, just add the step size. 0 plus 1 is equals to 1. Then x2 is x1 plus h. Then just add the step size or previous number and step size. x1 plus h, 1 plus 1, 2. x3 is x2 plus h, 2 plus 1 is equals to 3. x4, x3 plus h is equals to 4, 3 plus 1, 4. Then find the function value. After putting the this x0, x1 up to the xn value in the function, then we'll get the f of x0, x1, x2 up to the xn or x4. F of x0, how to find y, or we denote here the y0, y0, y1, y2. A function is given e raised to x. E raised to x, put the value of x0. x0 is 0. e0, e raised to 0 is equals to 1. Then f of x1, we denote here the y1. Put the value of x1 in the function e raised to 1 is equals to 2.7182. Then x2 e raised to 2, 7.389. x3 e raised to 3, 20.085. e raised to 4, 54.598. So after calculating the all values of x and function values y0 to yn, put the all values in the Simpson's 1/3 formula. So we have the Simpson's 1/3 formula. Okay, apply here the Simpson's 1/3 formula. So here in the general form there is a h by 3 y0 plus yn first term plus 4 into odd terms plus 2 into even terms. So we will prepare here the for the our particular function or particular limits. Then h by 3. Here yn is in our case or in this numerical there is a 4 y4 y0 plus y4 plus 4 into odd terms. Odd terms are here y1 and y3. y1 plus y3 plus 2 into even terms. There is a 2 into y2. So this is a formula for particular or problem or numerical. Then put the all values. H is here 1 by 3 into bracket y0 is 1 plus y 4 is 54.598 plus 2 into odd terms y1 2.785 plus y3 is 20.085 plus 2 into even terms 7.389. So after simplification we'll get the area, that is 50. So in this way we can calculate the area under the curve using the Simpson's 1/3 rule. Thanks for watching.